All right. Please put somewhere on the top assignment number 17. So when we do have that binder check, more than likely in December, and everything will just be in order. Again, really nothing new. So we just got to review some things because we haven't done this in so long. What are the three methods of solving for systems of linear equations? Actually, go ahead. Yeah. Do you guys remember those three words? Substitution, yes, and so that was the second one, substitution. There was a term for add down. What was Elimination. That? Elimination, yes. So that was the last one. How about the first one? Graphing. Yeah, I mean, it says right over here, graphing. so yeah, graphing. So that was the first one. Okay. Now when we move on to number 2, your three possible solutions, and I've been kind of just saying it all throughout this time, we either have a intersection x comma y, and that just means that the lines intersect, whether we do graphing, substitution, or elimination. Okay. Whether we do any of these three, our second possible option or solution is no solution. What do the lines look like if there are no solution? Parallel lines. They don't intersect at all. What is the last possible solution that you could write as your answer? Infinite solution. It's infinite solution because they're the same line. The line is overlapped on top of each other. They intersect every single point on each of the lines since they overlap. Okay. So what we will do is we'll do some graphing, we'll do some substitution, we'll do a mental health break, and then we'll continue on with elimination. Okay. But we're not going to do every single problem. We'll probably do only some problems together. When I'm done teaching today, then you guys will do the rest. Okay. So let us start with number 3. And let's go ahead and start graphing these. So I think the first one, I'll do this in blue, I guess, or dark blue. This is a horizontal line. Okay, so with your straight edge or ID or ruler, y equals 2. And so that can be graphed like that. Now in orange yellow, y equals 2x. This is not a horizontal line. If we don't see a y-intercept, we can rewrite this as a plus 0. Okay. So y equals 2x plus 0. So that means for us, we will start on 0, 0. Your slope is 2 over 1. You're going to go 2 up, 1 to the right. 2 up, 1 to the right, 2 up. Any questions on number 3? Any questions? Oh, I'm not even done. Thought we were done. Anyway, circle your point of intersection, if there is, and then we'll write the actual coordinate point in x comma y, 1, 2. Okay. Now, are there any questions? If there are no questions, you guys will do number 4 during classwork time. Let's go ahead and skip over to number 5. Okay, we're at number 5 now. Okay, sometimes the lines are not in y-intercept mode, so let's go ahead and manipulate some of these equations. So I'm just going to take the top equation. Let's do some transferring over on the right side here or wherever you find space. Okay, we need to solve for y. We need to have y by itself. So what do you think you're going to do with this positive 1x? Sorry, what's that?
Minus x.
We're going to minus x on both sides because we want y by itself. A4, negative 40 minus x is negative 41. Is that correct?
No.
No. These are not like terms. And so just write them all in one line, negative x minus 40. For these problems, I like putting the 1 over here because we're going to be dealing with some slopes. So if you need to put that 1, please go ahead and do so. Last step, please. By what? 5. Okay. So just be careful. Again, some students think negative 1 divided by 5 is negative 5. That's incorrect. What is negative 1 divided by 5? Negative 1 over 5. So just leave it like that. And then we'll put the x over here. We definitely can do the second one. Negative 40 divided by 5? Negative 8. So there we go. So now we have it in slope-intercept form. Let's go ahead and graph this right now. Okay. So negative 8 over here. What does negative 1 over 5 mean for your slope? 1 what? 1 down, 5 to the right. All right, students, wherever you see fit or wherever you see some space, let's go ahead and manipulate the second equation. So x minus y is equal to 2. Very similar to the first thing that you did. We're going to subtract x on both sides. Minus x minus x. So let me just zoom in over here. So we have negative x plus 2 on the right side. Students, be careful. What are you left over on the left side? Negative y. Very good. Negative y. And then, of course, if you want to write down the 1, I think it will be helpful, especially since we're doing slopes. Okay. Now we can divide both sides by negative 1. When you multiply or divide by negative 1, it just means all the signs change. So this is going to be positive 1x minus 2. And let's go ahead and graph that. Negative 2 is your y-intercept. And then our slope is 1 over 1. So that means 1 up and then 1 to the right. If your lines are a little crooked, that is okay. Just kind of guesstimate where it should be intersecting, and it looks like it intersects over here. So what is that coordinate point, you guys? Negative 5, comma, negative 7. Okay. Negative 5, comma, negative 7. Graphing is good just because, especially for the visual people, there's a visual representation. Like, okay, I graphed these two lines. This is where they need to intersect. But one of the problems with graphing is if your lines are just 1 millimeter crooked on both of them, then your intersection points can be a little bit off. Okay, so that is one downfall of graphing. So hence, we use other techniques like substitution. So you're going to do number 6 on your own during classwork time. Let's do substitution on the next page. Less. We're going to do number 9, and then after that, we'll take a 1 minute and a half mental break. Is that okay? Okay. Let's go ahead and do number 9. Again, so 7 and 8, you guys will do it on class time. Instructions and substitution. If you have two equations, that's y equals and y equals, your setup is going to be, and I gave you a hint, y equals y. Okay. You're going to cross off this first y and put the expression negative 2x minus 20. What would you guys put here after the equal sign? Three x plus 15. 3x plus 15. Okay? Since they're both equal to y's, they're both equal to each other. So put this on the left and put the second one on the right. Okay. Now it looks like something you've been solving. Some students like to subtract 3x on both sides. You could have also added 2x on both sides. It does not matter. Okay. Negative 2 minus 3 is negative 5x. So not too bad with this type of math. Add 20 on both sides. Negative 5x equals 35. Okay. And we'll not sort of box that, but we're just kind of taking notice of it. Okay, negative 7. What do we do next with the negative 7? Yes. And you can plug it in on either one. Let's just choose the first one. You could have also plugged it in on the second one. Y equals negative 2x minus 20. Y equals negative 2 times negative 7. And then you're just going to do PEMDAS on the right side. Negative 2 times negative 7 should be positive 14. And then positive 14 minus 20 should be negative 6, I hope. And please make it into the order of x comma y.